Hello everyone. Welcome back to the channel. I'm Sanket Singh. I'm working as a software engineer at Google. And this is the third video of the 10x Engineer Bootcamp. We have already posted two videos where I talked about basic number system and writing your first Hello World application. I know both of the concepts are pretty basic. And for a few more lectures, we will be covering a lot of basic concepts around C++ and the DSA part along with the dev. But after a few lectures, you will see that a lot of more advanced concepts around problem solving, algorithms, different data structures, and some more concepts are going to come up. So stay tuned for that. In this particular lecture, we are going to talk about a bunch of things around operators in C++, and we'll see how they work. So if you are someone who is not very much confident with that topic, or even if you have already learned that topic, I would highly recommend you guys in any of the situation to definitely give the video a shot. Do watch the video till the very end. I have like there is one simple motive always to make sure that whenever you are watching any video that I'm going to put on the channel, you learn something new every day. So that's the main agenda. So make sure you do watch the lecture up till the very end. And if you have any thoughts, any comments, do drop them in the comment section. I would be happy to accommodate any of your suggestions. And if you really like the series, two videos are already up and we will try to put all of the remaining videos as soon as possible. So do share it with your friends and in your college so that we can actually reach to more wide audience of people. That being said, without any further delay, let's just start. So before starting the video, I would like to tell you about Algocamp.io. So if you are someone who is going to prepare for your upcoming coding interviews, you are someone who already knows basic problem solving and basic data structures and algorithms, and now you want to just kickstart your journey, or I would say level up your journey for your interviews in, let's say, next upcoming 3 to 4 months, where your target is to solve as many good hard problems as possible that are going to be asked in the top companies, then you can definitely go and check out the top coding interview problems course on algocamp.io, where we are going to solve more than 400 problems live as well as in hybrid recorded manner. It's a completely power packed course where we have picked not only just the data structures and algorithmic topics, but we have picked specific lectures where we are going to talk about specific techniques on every data structures and algorithm. For example, you can see there is dedicated lecture on problem solvings on arrays, then dedicated separate lectures on two pointers. Then you can see there is dedicated specific lecture on time and space complexity analysis and their problem solving. Then there is a bunch of revision lectures because we know that recursion and backtracking still pains a lot of students. So there are a bunch of revision lectures for that. Then we'll talk about maths, we'll talk about modular exponentiation and matrix exponentiation because a lot of questions around these are asked in online coding tests. Then we'll talk about problem solving around sorting, basic sorting algorithms, then dedicated problem solving around merge sort based problems, and of course not just inversion count but major wide variety of problems around merge sort, then quick sort and similar techniques around quick select algorithm, binary search, and you can see dedicated set of lectures around binary search on answer, minimax problems, binary search on real numbers and whatnot. Then linked list, you can see there are dedicated lectures on stacks, there is dedicated lectures on queues, binary search trees, binary trees, heaps, hashing, DP, tries, string algorithms, and all the different variety of DP along with graphs, DSUs, MSTs, and whatnot. And there will be a lot of mixed problem solving lectures that will happen. This is definitely not a lecture or not a course where we are going to talk about any cakewalk level problem or something. Everything that we are going to pick is going to be medium or lead code hard, or the problems are going to be from code forces or code chef, right? This is something that you can definitely try and check it out, and you can use the code algocamp 500 to get a flat 500 rupees off on this particular course. It's going to be something really power packed and something that you should definitely check it out. So if you are someone who is preparing for their coding interviews, do check out this course and you can check out more things around algocamp.io. So now let's just move back to our video. So now we are going to discuss things around operators, right? What are operators and what we can actually do with them is something that is going to be very interesting, right? Operators as a concept not only exist in C++, but this concept exists in other languages also, right? Operator as a concept exists in other languages also. So what are operators? In simple terms, if I explain you, these are symbols. These are symbols that perform different operations that perform different operations on variables and values, right? So what operators are going to do, operators are just a bunch of different symbols. Every symbol actually resembles a different type of operation, and these operations you can do on different variables or directly on value. For example, if you do 10 plus 2, so here this plus is the operator, and this 10 and 2, these are called as operand. What is an operand? What is an operand? Operand is a value on which the operation is done. Value slash variable on which operation is done, right? Whereas operator is the operation which will be done, right? So in simple terms, there can be different symbol. For example, plus, this minus symbol, asterisk, there can be different symbols, right? Every single will actually denote different operation. For example, in this case this symbol actually resembles addition of two numbers. This plus symbol resembles addition of two numbers. So this operation can be done on different variables and values. So currently I can show you that these are the values, 10 plus 2. You can even have two variables. You can even have something like this. So let's say x is equals to 10. Let's write it separately. Int x is equals to 10, int y is equals to 20, and you do int c is equals to x plus y. So here you can see the operands are actually variables rather than exact values, right? So this is something also you can do. So these operations are going to be done on either variables or values, and there can be different operations. So one by one we are going to actually talk about these operations and actually understand the use cases around them, right? And it's going to be extremely easy. At least a very good set of operators are going to be very easy to understand. Okay, cool. So if I talk about this, we can say that there are different type of operators, right? So these operators or these symbols we have categorized, right? So let me write it in a bigger note. So let's say the first type of operators are called as arithmetic operators, right? What are arithmetic operators? These generally do mathematical arithmetic operations. Arithmetic operation means addition, subtraction, and all, right? So there are different arithmetic operators. So if I talk about the arithmetic operator, there is a plus operator, minus operator, asterisk, there is a division, and there is a modulo, right? So this is, you can say, plus, this is minus, this is asterisk, this is slash, and this is modulo. Okay, we'll talk about each one of them. So let me write a basic C++ code. Let me write a basic C++ code. So hash include. Okay. So let's start from here. Okay. So the boilerplate is ready. Let's start. So first of all, let's say you have two variables. Int x is equals to 7. Int y is equals to 3. Okay. We have two variables. If I do std cout, sorry, if I do std cout x plus y, right? And then I can give a new line character. Okay. So, 1 second. std cout. Then similar to x plus y, we can have a few more operations. Okay, we can have x minus y, x into y, x by y, x mod y. Okay, so we can even write it like this, right? Let's try to make sure we are making good logs, or let's for the timing keep it like this. Okay, cool. So if I run this piece of code, you can see for x plus y I'm getting 7 plus 3 is 10, which is technically doing what? Addition. Then x minus y I'm getting 4, so 7 minus 3 is 4, this is subtraction. Then x into y, 7 threes are 21, so this is multiplication. This is division, because 7 by 3. Now the interesting part is 7 by 3 is what? 2.5, right? If you completely try to divide 7, you are going to go into fraction, and then you are going to get something like 2.5, but the answer we are getting is 2. So why we are getting 2? Because in C++, specifically in C++, different languages can handle it differently. If you do something like this in C++, if you do something like 7 by 3, so this is technically what? This is a floor division operator. Floor division means whatever is the answer, we return floor value of it. What is a floor value? So for example, if you have something like 6.5, so the floor value of 6.5 is going to be 6. So it is going to reduce itself to the just lesser integer value. If you have something like minus 13.2, it is going to be what? What will be the floor value? So you are going to just remove the decimal part and reduce yourself to the just lesser part or lesser integer, that is minus 13. If you do 6.9, this is also going to be 6, right? So a lot of time you represent floor value with something like a symbol of this is the symbol of floor values in mathematics. Whenever in mathematics we have to say that we are going to calculate floor values, we just write it like this. So we have a straight line followed by a bar to the bottom. This is floor value. There is something called as seal also. There is a concept of seal values also. What is seal value? Seal value is represented by this. If you do something like 7.8, the seal value is going to be just one greater than 7.8 integer value, that is 8, right? This is the seal value. But in C++, this division is actually going to be done as floor division. Floor division means whatever is the quotient, let me even write it here, quotient will be floored, right? Whatever is the question, this is going to return the quotient of the division. That is something that you need to keep in mind, and for that quotient you are going to return the floor value. At last, this is the modulo operator. Modulo operator actually returns remainder of the division, x by x. That means when x is divided by y, what is the remainder, right? So this is actually going to give you remainder. So you can see, right, if you divide 3 with 7 and you just reduce it to an integer value in the quotient, you're going to get 1, right? Because 3 2s are 6, so the remainder will be 1, and hence it is going to give you the remainder. So these are arithmetic operators. Arithmetic operators are going to give you some mathematical arithmetic operations based on which you can do different things and based on which different logics can be developed. Now there are a bunch of operators. There are a bunch of operators called as assignment operators. What are assignment operators? Used to assign some value or compute a value first and then assign. Okay, so it can, assignment operators can be done can be used to either assign a value directly or maybe to compute a value first and then assign the value, right? So let me show you. So this operator, if I somewhere write int x equals to 10, right? So this operator, this is like a assignment operator, right? It is one of the assignment operators. Equals to, why assignment operator? Because in the variable x, in the variable x, we are assigning value 10, right? So this value technically gets assigned to x, right? So that's why this is an assignment operator. Equal to is considered as an assignment operator, right? So apart from this equals to, there are more assignment operators. For example, you can do something like, let's say x plus is equals to 10. Okay, x plus is equals to 10. Now here also things are very interesting. This plus equals to is also a assignment operator. Once again, this plus equals to is also an assignment operator. But now you might be thinking, what is plus equals to doing? So what plus equals to actually does is, it first add 10 to the current value of x, and then assign this value, or assign this new value back to x. So what it is actually going to do, for example, let's say, let me write it here. So for example, if let's say x is equals to 23 and you did x plus equals to 10. So what this operation is actually going to do, currently in the bucket of x you have 23, right? And you want to add 10 to it. So what it will do, it will first of all do 23 plus 10. What is 23 plus 10? It is 33. And then it will try to assign 33 to x. So it is equivalent to, this operation is equivalent to saying x is equals to x plus 10. That is, you are first going to add 10 to the old value of x, and then whatever is the value, you assign it back to x. That's why it is also an assignment operator, right? And similar to plus equals to, for other arithmetic operations also you have a corresponding assignment operator. So let me show you. So let's say we can do something like x, let's say we do int c is equals to 18. So this is equals to is a assignment operator, assigning value 18 directly to c. Okay, this is one of assignment operator. I guess we can just quickly see out it and actually see the result, right? Okay, apart from that, you can do something like c plus equals to 3. So first add 3 to original value of c, or I would say current value of c, and then assign this new value to c. Okay, so if you do c out here, you can see, right, 18 plus 3 will be what, 21. So here technically the answer should be 21. Okay, we'll see when we run it, or we can just quickly run it also. Just run it. You can see the answer is 21, right? We are getting the correct answer. And similar to plus equals to, you have something like minus equals to also. Let's say if I do c minus equals to 5, So what it will do, it will first subtract 5 from the current value of C and then assign this new value to C. Okay. So current value of C is what? 21. Current value of C is 21. What is 21 minus 5? This is going to be 16, right? So 16 should be allocated to C. So if I try to do C out C, my answer will be 16. Let's run it. You can see we are getting the answer as 16. So it's computing it as 16. And similarly, we have more assignment operators. So for example, I can do C star equals to 2. So I believe everyone can understand what actually I'm going to do here. So firstly, it will multiply. It will multiply 2 to the current value of C and then assign this new value to C. So what is the current value of C? 16. 16 twos are 32. So if I do std C out C, the answer should be 32. Here we should get 32. If you run it, we are getting a 32. Okay, makes sense. Now, similar to that, we have C divide equal to, let's say, 3, right? So I guess this is also very straightforward. We are going to first divide C by 3, right? And then assign this new value to C. So what is the current value of C? 32. 32 by 3 is what? 32 by 3 is 10 point something, right? So we'll just get the floor value. That means we should get 10. So if you do std C out C, this value should give us 10. And you can see we are getting an answer as 10. And at last, you can have something like C mod equals to, let's say, 5. So I guess this is going to be pretty straightforward. You are going to first divide the value of current value of C with 5, and whatever is the remainder, you assign that remainder to C. So what will be remainder of the division of 10 and 5? Can I say 0? So if I just print it here, technically I should get a 0. So if you run it, and we can see we are getting a 0. So these are the different set of assignment operators. Assignment operators can either directly assign a value. When I say directly assign a value, I am technically referring to this, that we are directly assigning the value 18 into C. But there can be some cases where you have to first compute the value. For example, you are going to first add 3 to C. So you are going to do some computation, and after that computation, you're going to assign that value back to C or to any variable, right? Same thing here, minus equals to, star equal to, divide equals to, and multiply equals to. So these are the different cases in which you can use the assignment operator. So the next set of operators are relational operators. They determine relationship between values, or you can say variables. Relationship means they are going to compare them. You can even write after comparing them, right? So they actually compare the values and try to find the relationship. For example, if I do std C out, what's the value of x? X is 7, right? So I can do something like x double equal to 7, right? So here this is a double equal to operator. So in my system, you might see it as a extended equals to, but it is technically a double equal to. It is something like this. In your system, you have to just press equals to twice. This is in my system represented as this. It's due to the difference in font. I'm having a different font. That's why I get a double equal to like this in this font. So technically I'm doing x double equals to 7. Double equals Double equal means it checks if x is equal to 7 or not, right? So it is going to check whether x is equals to 7 or not. If x is equals to 7, it is going to return a true, because relational operators are going to return a true or a false value. Returns true or false values, right? Based on what relationship you have and whether the relationship is qualified or not, based on that you are going to return a true or a false value. For example, you can do something like std cout. You can have a no, less than operator also. Less than means something like this. It will check whether x is less than 4 or not. Now you can see the value of x is 7, right? Is x less than 4? Current value of x is current value of x is 7. So technically if you replace 7 here, is 7 less than 4? Do you think if I compare two values, 7 and 4, and I ask you a question, is 7 less than 4? What should be the answer? So is x less than 4? Is x less than 4? We will say no. 7 is not less than 4. So for the first condition, the answer should be true. For the second condition, the answer should be false. If you run it, you are getting a 1 and a 0. What is 1 and a 0? So in C++, whenever you actually try to get a Boolean value, until unless you manually print it, if you try to compute a Boolean value, for example, we computed, right? We got a Boolean value. We didn't directly print a Boolean value. Like I didn't directly do cout true. I computed it. Like is x equals to 7? So it computed it to a Boolean value. Whenever we compute a Boolean value, so for a true we get a 1 and for a false we get a 0. That's the overall, I would say, idea around C++. This is like a very old convention that exists in C++. It's a very old convention that exists in C++, right? Now, if you try to do some more operators, that whether x is greater than 3. Now, x, the value of x is 7, right? So it is going to ask the question, is x greater than 3? Okay. So is x greater than 3? 7 greater than 3? You can say yes, so answer should be 1, or you can say true. This one is actually representing a true. Okay. I'll talk about how this interconversion works, right? Then you can have something like greater than or equal to. So is x greater than or equal to 8? So this is x greater than or equal to 8? So answer should be no. 7 is not greater than nor equal to, because it will check whether the value is greater than 8. If it is not greater than it, is it equal to it? Something like this, right? So you will get a 0. And on this similar note, you have something like less than or equal to. You have something like less than or equal to. Okay. So let's say less than or equal to. Okay. So we'll check, is 7 less than or equal to 7, let's say. So is 7 less than 7? No. But is 7 equal to 7? Yes. So the answer should be 1. See, answer is 1. And if you, let's say, do it like this, if let's say x is less than or equal to 10, right? Is x less than or equal to 10? Now you can see value of x is 7. Is 7 less than 10? Yes. So you don't even have to check for the equals. If you run it, so yes, 7 is less than or equal to 10, right? So for this, you actually pronounce it like this, less than or equals to. So either it can be less than or at least it can be equal to, then only we will return a true. Finally, you have something like, is x not equal to? So not equal to is a symbol like this. And again, I have a different font, so I'll write all of the symbols here. So less than or equal to is this, less than, equal to. This is greater than, equal to. Like in your system, you have to just put a greater sign and then an equals. And this is a not equals. I might, in my system it might show a different font, that's why you might see the symbols are a bit different. So when I do not equal to, it just changes the symbol, so it's due to font. Okay, so you can say whether the value of x is not equal to 3. Like, you ask a question, is 7 not equal to 3? Yes, it is not equal to 3. So is 7 not equal to 3? Right, we'll say yes, it's not. So the answer should be true. That means the answer should be true, right? Because it's not equal to 3, it's a true statement. So you try to actually validate the existence and the overall computation. You ask the computation of the statement, that is x not equal to 3? Yeah, it's not equal to 3, it's a true statement, right? So if you run it, you get a 1 again. So these are the different set of relational operators that exist inside C++. So before we move on to further operators, you might realize that from quite some time in my actual C++ code, I am able to write these random text, right? I'm able to provide you a piece of information about the code that I'm writing, but it is not anyway related to C++ syntax, right? Syntactically, C++ is something like this, but I'm able to write something like addition, plus, minus, asterisk, things like these, right? So these things where you are able to provide some piece of text, and this piece of text is going to be absolutely ignored by the C++ compiler. C++ compiler is going to ignore all of these piece of texts, are called as comments, right? So let's talk about comments. So this concept of comments not only exists in C++, but it exists in other languages also, right? Comments. So what are comments? What are comments? Right? These are hints or information about the code. Whatever code I am going to write, these comments are going to provide hints that what is the code, or information about what is the code to the reader. These make the code easier to read, right? Comments make the code easier to read, because whenever we will be just reading the comments, we can just we will be just reading the code, we can just go through the comments and then understand what the code is actually doing. Can I say that? Right? Comments are ignored by C++ compilers. C++ compilers are not going to get hindered by the existence of comments. They are going to just avoid comments. Whenever they see a comment, they're just going to avoid this, because their main focus is going to execute the C++ code. So there are two ways in which you can make a comment. You can make a comment like this, right? So you can put a pair of double slashes. The moment you put a pair of double forward slash, and technically this is pair of double forward slash, you can write a single line. You can write a comment in a single line. If you want to write comment in multiple lines, you have to do a forward slash followed by an asterisk. Then you can write multi-line comment. You can write your comment in multiple lines, and then close it with a star slash. Close it with a star slash. So let me show you. So for example, if you see, I wrote a single line comment here, a single line comment here. That is, the comment starts in the line and it ends in the same line. But here you can see I was using more than one line. So instead of using two single line comments, what I can do is I can say slash star and then stars slash. Okay. Now if you see, we are able to write multiple comments in multiple lines, and we have just binded it inside star slash and slash star, right? So these are multi-line comments. So comments are just basic piece of information that you can give to user. It makes the code more readable. Whenever you will be working in a team with some fellow developers, you will see that they have also written some logic, and you can't just always go and ask them that what is this logic all about. Rather than if they will just quickly write a comment, you will just read the comment and understand the overall logic of the code. That's important. So this is the meaning of these comments. That's why whenever I was writing all of these random text, there was no issue that was that the compiler was raising. So the next set of operators that we are going to talk about are actually logical operators, right? Now, if you're someone with a bit of experience in programming, you might have heard about it, but we are going to discuss some more in-depth details which are not covered very much out there, right? So what are logical operators? Before you actually understand logical operators, you need to understand something called as logic gate. Now I'm assuming that you must have heard about logic gates. You must have seen symbols like these, right? These logic gates you must have seen, right? Something like this. So these logic gates you might have seen. So there are different logic gates: AND gate, OR gate, right? If I talk about AND gate, so basically we are going to focus on three: AND gate, OR gate, NOT gate, right? So AND gate is what? It takes two input, and both the inputs are actually currents, right? So in one input, if there is a current, so it's consider it as a boolean 1. If in the other input, if there is no current, it will consider it as boolean 0. So it is logic gates actually work on booleans, right? Because boolean are able to represent whether there is a current or not. If there is a current, you represent it as boolean 1. If there is no current, you represent it as boolean 0. So if you try to see what will be the output of an AND gate, if one input is X, one input is Y, can I say these can be the four different combinations, that both the input can be 0, both the input can be 1, or one input can be 0, other can be 1. In this case, the output is 0, 0, 0, 1 for AND gate. If I talk about OR gate, X, Y, and then output. So 0, 0, 0, 1, 1, 0, 1, 1. 0, 0 is 0, 1, 1, 1. This is OR gate. NOT gate is a single input gate. So you can give an input X and you can directly get an output. So if you just have a single input, so either it can be a 0 or it can be a 1. Output will be 1 or 0, right? This is the NOT gate. So I believe everybody must have heard about these gates. Now in C++ also, you have a replacement of a situation like gates, right? So you have something like logical operators which technically act as these gates. So we have different logical operators. So we have AND operator, logical AND. We have logical OR, and we have logical NOT. How do you represent logical AND? So there are two ways in which you can represent logical AND. One way is you can write something like A and D. In C++, you can write something like A and D. It will act as a logical AND. Otherwise, the other way is you can use two ampersands. This is the ampersand symbol, right? So you can use two consecutive ampersand symbols and actually represent logical AND operator. For logical OR, you can write something like OR. Otherwise, you can use two pipes. These are two pipes, right? Let me write it here. These are two pipes. Pipe symbol is there. It's not I, it's not L, it's pipe. And for logical NOT, you can write something like NOT, not, or you can use a single exclamation to actually represent logical operators. So in C++, the same operator can be used in or represented in two different ways. You can write A and D, or you can write double ampersand for logical AND. You can write OR, or you can write double pipe for logical OR. You can write NOT not, or you can say a single exclamation for logical not. And they act in a similar way. If let's say you are using an AND operator, now the operands of the AND operator will be evaluated as a boolean, right? Will be evaluated as a boolean. Why the operand will be evaluated as a boolean? Because you can see, right, the logic gates only expect boolean values. They are going to replace logic gates for us, so we need to actually have boolean values only, right? So let's say if you do something like 3 less than 5, 6 not equal to 6. Okay, let's say you have a statement like this. Now you tell me, is 3 less than 5? Now this is what? A relational operator. Is 3 less than 5? Is the value 3 less than 5? Yes. So it's a true, right? Then you see, is 6 not equal to 6? Like, are the values of 6 not equal to each other? They are equal to each other, right? So this statement is false. And what is the operator you have in between? And. So what is true and false? True and false means true is 1, false is 0. What is 1 and 0? 1 and 0 is 0. So the overall answer is going to be false, right? Overall answer is going to be false. Let me show you with an example. So now we are talking about logical operators. Logical operators, right? What are logical operators? Logical operators evaluate operands as Boolean and then apply logic, Boolean logics. Boolean logics. Okay, for example, if I do std out, is 3 less than 5? And you can write something like a and d and 6 not equal to 6. So what is the output? One second. So there is some mistake that I made. One second. The x not equal to 3. One second, let me run it again. Okay, yeah, I guess I made some mistake there, but it's now fine. And you can see we are getting a 0. What is the equivalent of false, right? What did I tell you? When you're going to get a false through a computed value, I didn't just do cout false, right? Here we are computing the value false. Whenever you compute the value false, C plus is going to convert it to a 0 or a 1. So hence we are getting the output as 0. And as I said, logical AND can be represented in two ways. Either you can write A and D or you can write double ampersand. So if I write the same to same condition with a double ampersand, you're getting the same output, right? So both of these are logical AND. Both of these are logical AND, right? So let's try for a few more conditions. And try to understand it a bit in a more in-depth, right? So now let's say you have something like 3 not equal to 5 and 3 less than 5. Okay, now let's see. 3 not equal to 5. Is the value of 3 not equals to 5 or different than not equal to 5 or different than 5? Yeah, it's different. Like both of them are not equal to each other. So it's a true value. Is 3 less than 5? Yes, it's a true value. And the operand that you are using is AND. So true means 1. True means 1. 1 and 1 is 1. So the overall answer is going to be what? True. And true will be converted to a integer 1 because we are computing 2. We are actually retrieving 2. We are not just directly printing 2. So if I do something like std out 3 not equal to 5 and 3 less than 5. Okay, if you run it, we are getting an answer 1 because the condition is true. You might be feeling that why I'm putting a lot of parentheses. This is just to segregate the expressions well, right? Let's take a few more examples. You can say something like, let's say you have 3 not equal to 5 or 3 greater than 5. Okay, 3 not equal to 5 or 3 greater than 5. Now, is 3 different than y? Yes, it's a true value. Is 3 greater than 5? Is 3 greater than 5? No, it's not greater than 5. It's a false. and the operator that you're using is OR. So true is 1 or false is 0. What is 1 or 0? 1 or 0 is 1. So the final output is going to be what? True. True means we are going to return a 1 and we are going to actually print a 1. So if you do std cout 3 not equal to 5 or 3 greater than 5. If you run it, see, we are getting true. And as I said, instead of just OR, you can use double pipes. You do the same thing by using double pipes. Pipe symbol is in your keyboard most probably the pipe symbol will be along with the backslash. Okay. Now if you try to run it again, see the same output. So this is logical OR. We are doing logical OR. And similarly, we have logical NOT. So logical NOT is going to be what? We just need one operand. For example, is 3 less than 5? And you put a NOT operator, let's say. Is 3 less than 5? True. What is not of true? What is not of 1? Can I say false? And this false is going to actually return a 0. So if I do std cout 3 less than 5, we are doing logical NOT. Okay. See, the answer is 0 because 3 is less than 5 is true. Not of true is false. And the same thing you can also do by just writing NOT. So if I say not of 3 less than 5, if I segregate it properly and if I run it, see, same output, absolutely, right? So these are the three different type of logical operators, right? So in logical operators, whenever you give an operand, that operand is going to be evaluated as a boolean. That what is the boolean equivalent of the operand? For example, 3 less than 5, the boolean equivalent is true because 3 is less than 5. So whatever is the boolean equivalent of the operand, you are going to convert the operand to that. So converts the operand to the boolean equivalent, right? To the boolean equivalent. For example, is 3 not equal to 5? So yes, true, right? It's a true value. So boolean will be true here. And then both, few of them, for example, and or, they require two operands, whereas not only requires one operand, right? Not only requires one operand. So based on this, we can have different operations. For example, logical and, logical or logical not. In logical operators, you don't have a XOR. You don't have a XOR here, right? You only have and, or, and not, and they can be represented like this. But there is a very interesting question that I want to ask you guys. Here I'm always writing some condition, right? I'm writing some relational operation or conditional operation. Nobody generally thinks, but maybe, how about if I do 3 and 4? Is this a wrong expectation? If I do 3 and 4 and if I run it, the answer is going to be a bit strange, but the answer is going to be 1. Why 3 and 4 are able to work here properly? This is something that we need to talk about, right? You can even do 3 and 4. Same thing will happen. See, 3 and 4 and same thing is happening. So exactly what is going on? Try to spend some time, spend some time and think about what is going on here in 3 and 4. So there is a bunch of lines in front of you, and these lines, like from line number 49, if you specifically see here from line number 49, you don't see any type of conditions that directly get evaluated to a boolean expression, right? You are able to see 3 and 4, or you're able to see 3 and 4, right? And apart from that, you are able to see a minus equals to 2 and b plus equals to 3. So these are not conditional statements. So what is going on here? So as I said, as I said for logical operator, that logical operator converts the operands to the Boolean equivalent. Now in C++, if you do 3 and 4, all the integers, all the integers apart from 0 are evaluated as true. So this 3 and 4 will be evaluated as true. True and true is going to be true, and hence the answer is 1. Even if you do, let's now try to do minus 3 and 4. If you do minus 3 and 4, right? So see, so last is 0 3, this is the second last, and you're still getting a 1, right? So even if you do minus 3 and 4, minus 3 is also true, 4 is also true, true and true is true, true is evaluated to 1. But if you do, let's say, something like 5 and 0, or you do something like 0 or 0, so 5 is true, 0 is false, true and false is false, right? True and false is false, and this gives you a 0, right? So only 0 is the falsy value here. So that is why in C++, when you do 3 and 4, you get a true. You minus 3 and 4, you get a true. If you do minus 3 and 0, or let's say 0 and 10, 50 and 0, in all of those cases, you are going to get a false value, that is a 0. Okay. So that's the explanation for line number 49 and 50. But what is going on here? What is going on here? This is something very interesting. In order to explain this, there exists a concept of short circuiting. What is the concept of short circuiting? Let's talk about it. So in Boolean AND gate, this is, let's say, the Boolean AND gate. This is, let's say, the input number 1. This is the input number 2. Okay. So what Boolean AND gate does is, if the first input is 0, it doesn't even check what is there in the input number 2. It directly just returns you a 0, right? You can even see, if let's say you have a value x, you have a value y, and you say x and y 0 0 0 0 1 0 1 0 0 1 1 1. Let's see what is going on. So what logical AND operation does is, if the first operand, it will evaluate the first operand. What is the value of, after the evaluation, what is the value of first operand? 0. If it is 0, it is not going to check even the second operand, it is going to directly return you a 0. Same here. If the first operand is a 0, it will not even check whether the second operand was a 1 or a 0, it will directly return you a 0. If the first operand is 1, there is a possibility the other one can also be 1. So in this case, it will check both of them. And now the second operand is a 0. The moment you detect that the second operand is a 0, it will immediately return a 0. At last, it will evaluate first as a true value, second as a true value, and then return the second value altogether, right? So you can say that if the first value after evaluation becomes falsy, then it doesn't even check the other value and return Boolean of first, right? Boolean of the first value. So otherwise, if first value is true, then it evaluates the second and returns the second. It returns the Boolean of second. You can see, right? If the first value was 0, it will immediately return you 0. If the first value is 1, whatever is the second value, that second value is evaluated and returned. See, if the first value is 0, you immediately return a 0. If the first value is 1, then whatever is the second value, you return that second value. This is the actual power of AND gate. And similar thing exists with OR gate also. If you do x, y, x or y 0 0 0 0 1 1 1 0 1 1 1 1. So what OR will do is it will check if the first operand is a 1. If the first operand is a 1, it will not even check the second operand, it will directly return a 1. It will directly return a 1. It will not even evaluate the second operand. If the first operand is 0, then whatever is the second operand, it will evaluate that and return that. So if first operand is 1, we don't evaluate second, directly return bool of operand 1, right? Otherwise we evaluate second operand and return that, right? So see, if the first value is a truth value, right, then you will just immediately return the first value. You will not even consider the second value, because OR gate doesn't care about it. OR gate just cares about the fact that whether at least one of the input is a truthy value or not. If one of the input is a truthy value, okay, we don't even need to evaluate. It saves time, right? We don't even need to evaluate y. But if the first value is not truthy, maybe the second value is truthy, so it makes sense to actually get the second value. Now what is happening here? When you have, let's say, a is equals to 2 and b is equals to 3, and what I'm doing a minus equals to 2, and I'm doing a logical AND with b plus equals to 3. Let's see what is going to happen. Now what is a minus equals to 2? You know about assignment operator. A minus equals to 2 is a is equals to a minus 2. That means 2 minus 2, that is 0. So you assign the value 0 to it. So this evaluates to 0, and 0 is a false value. And in a logical AND, if the first value is false, it will not evaluate the second value. So this expression is never executed. Never executed. This expression is never executed, and because you get a false value, you directly return this. That is why we first evaluated a minus equals to 2, and the value of a got updated to 0. But because this got updated to 0 and this is a falsy value, the other value will not even get checked. It will not be even evaluated. That is why if let's say you do something like this, std cout b plus equals to 10 or a plus equals to 2, and now you do cout a comma b. Okay, so cool, right? If now you run it, this should be another angle bracket. If now you run it, you can see the value of a is still 0, but the value of b got 13. Now what is going on here? In the next expression, what I'm doing is I'm doing b plus equals to 10 or a plus equals to 2. Now what is b plus equals to 10? The value of b is 3, right? 3 plus 10 is 13. So b will get this value 13, right? So we got a 13, and 13 is what? 13 is a truthy value. 13 is a truthy value. So in a OR gate, if the first operand is true, you don't even check the second operand. That means this is not evaluated, right? This statement is never executed. If this statement is never executed, nothing gets added inside 2. So this statement is absolutely ignored. We just execute this statement, we get a truthy value, and we just return a 1. And hence, you can see we are getting a 1 here. B got updated to 13, but A remains as it is as 0. And this is the concept of short circuiting. that you don't need to always evaluate both the operands. Based on the condition, if one of the operand will immediately detect what will be the answer, there is no point of evaluating the second operand. It will not evaluate the second operand, and this concept is called as short circuiting. So the next set of operators that we have are called as bitwise operators. Now, what are bitwise operators? We know that in programming, in computers, everything is just binary, right? And we just saw that something like 5 and 4, they are going to consider the Boolean value of 5. So by 5 is a true, Boolean true, 4 is a Boolean true. But there exists a set of operators called as bitwise operator. The name suggests bitwise. That means doing operation bit by bit. Doing operation bit by bit. So what is a bit? What are the different bitwise operators? So these are the different set of bitwise operators. I'll list them down here. A single ampersand, a single ampersand, a single pipe, right? Then you have a cap, right? You have a tilde, two forwards, or I would say closing angle brackets, two opening angle brackets. So let's talk about them. This is bitwise and this is bitwise or this is bitwise XOR, this is bitwise, this is XOR, and this is XOR, XOR. This is bitwise NOT, this is right shift, and this is left shift. Okay, these are the different bitwise operators that we have, and we are going to talk about all of them, and things are going to be interesting. Now if you see bitwise AND, every bitwise operator doesn't actually just looks at the value as a whole. It doesn't look at the value as a whole. Instead, if you do something like 5 and 4, what it is going to do, it is actually going to look at 5 with respect to its binary. What is the binary of 5? 1 0 1. What is the binary of 4? 1 0 0, right? So what it will do is, it will actually apply the AND operation on every single bit. That means, what is 1 and 0? 1 and 0, right? So if one value to the gate is 1, one value to the gate is 0, the final value is 0, right? So this is 0, 0 and 0 is 0, 1 and 1 is 1. So you got 1 double 0, and then it will finally convert it to again a decimal. So what is the decimal of 1 double 0? Can I say it is 4, right? So that's the essence. That's the essence. Let's take one more example. Let's say you do 6 and let's say 5. Okay, 6 and 5. What is the binary of 6? 1 1 0. What is the binary of 5? 1 0 1. So 1 1 0 1 0 1. You do an AND. 0 and 1 is 0. 1 and 0 is 0. 1 and 1 is 1. What is the decimal equivalent of 1 double 0? Can I say 4? So it is actually going to convert your operands into binary and explicitly go bit by bit to every given bit of the given binary number and then apply the operation. Similar thing you can say for OR also. So if you do something like 6 or I would say 5. Okay. So 6 binary is 110, 5's binary is 101, 110, 101, and you do a OR bit by bit. 0 or 1 is 1, 1 or 0 is 1, 1 or 1 is 1. What is the decimal equivalent of 111? Can I say 7? So 6 or 5 is 7. So we can start actually taking a look at it. STD out. If you do something like 5 and 4, 5 single ampersand 4. If you have double ampersand, that will be logical. See, if I will put a double ampersand here, it will be logical. Now 5 will be treated as a true value, 4 will be treated as a true value, final value will be true. That's a separate thing, right? But if you have a single ampersand, that's a bitwise operator. Okay. So the output of this expression 5 and 4 should be 4. Let's see. Once again, let's remove this extra character. If you run this, you can see you're getting a 4 here. 6 and 5. So 6 and 5 should give you a 4 again. See, it is giving you a 4 again. Now, if you see bitwise OR, so what is bitwise OR? 6 or 5. So technically, this should give you 7, right? Technically, this should give you 7. If you run it, we are getting the output as 7, right? So what is going on here? We are going bit by bit. We are going bit by bit, and on every bit, we are going to apply this operation. Now, there are few more operations that you can do. For example, bitwise XOR. So if I have something like 6 and I do XOR 8, okay, what's the binary of 6? You can say 110, and you can put a 0 behind it also, like preceding zeros doesn't make a lot of sense, but here it might. What is the binary of 8? 1000. Now if you do 0110 1000 with a bitwise XOR, how is the XOR table works? If you have x, y, and you do x XOR y, 00011011. If both the values are same, it gives you a 0. Otherwise, it gives you 1. Okay. So 00, 0 XOR 0 is 0. 1 XOR 0 is 1. 1 XOR 0 is 1. 1 XOR 0 is 1. Can I say that? Can I say that? And what is the value? What is the decimal equivalent of this? So if you want to convert it to a decimal, you can say 0 into 2 raised per 0 plus 1 into 2 raised per 1 plus 1 into 2 raised per 2 plus 1 into 2 raised to the power 3. This is 8 plus 4 plus 2 plus 0, 14, right? So if I do 6 XOR 8, 6 XOR is the cap 8. And if you run it, we are getting 14, right? So here we are actually doing 14. How we are doing a XOR, bitwise XOR. Okay. So these are the different type of bitwise operators. There are few more that we are going to talk about, but I hope this initial set of bitwise operators is clear to everyone. Now, what about the remaining remaining bitwise operators? So there is a bitwise operator called as left shift and right shift. What is left shift? Left shift means, for example, if let's say you have a number 7 and you do a left shift 1, 7 left shift 1. So what will happen? It will convert the 7 to a binary of 7, that is 111, right? And what it will do? It will shift all the bits to the left of 1, right? So let's say we were storing the number as a 4-bit number, right? Let's say we were having a 4-bit number, right? So what will happen? What will happen? This one comes here, this one comes here, this one comes here. This 0 gets eliminated because we can only store, let's say, 4 bits. Now we are left with the last bit, right? At the last bit, it will append a 0. At the last bit, it will append a 0. Let me give you one more example. Let's say you do 3 left shift 2. So what is the binary of 3? 0, 0, 1, 1. Let's say we have a 4-bit number. So what will happen is, it is going to shift everything by 2 places on the left direction. So technically this one comes here, this one comes here, these 2 zeros gets eliminated. So sorry, this 0 gets eliminated, this 0 gets eliminated, this one comes here, this one comes here. So you have 1, 1, and you have 2 vacant spots. In those 2 vacant spots, you are going to put a 0. You are going to put a 0. And what's the binary of this? Can I say this is, I guess, 12, right? Let me give you one more example. Let's say you have something like 5 and you do a left shift of 3, right? And let's say this time you are storing a 8-bit number. So 0 0 0 0 0 1 0 1. So this is, let's say, 8-bit number. So depends what type of like what different type of number you are saving. I'll talk about this when we'll talk more about how internally numbers are stored and everything. So everything will get shifted to 3 places. If everything gets shifted to 3 places on the left, so these 3 zeros will be eliminated. This 0 comes here, this 0 comes here, this 1 comes here, this 0 comes here, this 1 comes here. So finally we have something like 0 0 1 0 1, and you have 3 vacant spots. If you have 3 vacant spot, you will fill all of them by zeros. You will fill all of them by zeros, and then you can convert this decimal to a binary. Sorry, this binary to a decimal. So this is the left shift operator. So let me demonstrate the left shift operator in front of you. Let's say you do 7 left shift 1. If you run it, see we are getting a 14. That's correct. If you do 3 left shift 2, we are getting a 12, right? So this is what left shift operator is going to do. It is going to shift everything to the left by these many steps, right? So if you have something like a left shift b, so these are the steps. So this is going to shift every bit of a to in the left direction by these steps. Now if there is not, it's not like you can store unlimited number of bits. Let's say in your system you can only store a 4-bit number. 4-bit number means you can at max represent 4 bits to represent a number. So the last bit has no space to go anywhere, right? So it will be eliminated altogether and you will add something. So once you have shifted everything to the left, there will be vacant spots, right? There will be vacant spot. In all those vacant spots, you are going to put a 0. And the right shift operator is going to be exactly opposite of this in terms of direction. In right shift operator, what will happen is, if let's say you do something like 7 right shift 2, so what will happen? Binary of 7, let's say you have a 4-bit number 0 1 1 1. So everything will be shifted by 2 places. That means the last 2 bits are going to get eliminated. This bit gets shifted here, this bit gets shifted here. So you have a 0 1 and 2 spots are vacant. In both those 2 spots, you're going to put a 0, right? If you do something like 6 right shift 1, binary of 6 0 1 1 0. So everything gets shifted by 1 spot. This 1 comes here, this 1 comes here, and this 0 comes here, right? So you have 0 1 1 and you have a vacant spot. You have a vacant spot here. In that vacant spot you will put a 0, and this is the binary of 3. So technically, if you carefully realize, when we were doing left shift by one place, it is technically doing what? It is doubling the number 7 into 2, because we have already discussed this in number system, right? That if you put a 0 at the last or append a 0 at the last of the binary, it will technically try to double the binary or double the exact value. If you see 2, 3 left shift 2, so you are first doing 3 into 2, that is 6, and then you are doing 6 into 2, that is 12. So if you do shift by 2 values, so you are doing the value of 3 double twice. So first it becomes 3 into 2 6, and then it becomes 6 into 2 12, right? So you are doubling it. Whereas here, if you see, if you do 6 right shift 1, you got a 3. That means you are doing 6 by 2. If you do 7 right shift 2, so what is 7 by 2? This is 3, and what is 3 by 2? It is 1. So you are doing a division twice. So right shift actually represents a division, and left shift actually represents a multiplication, right? That is why if let's say if at any point of time I say 1 left shift 3, that means what is the binary of 1? Let's say you have a 8-bit number 0 0 0 0 0 0 0 1, and you shift it by 3 bits. So what will happen? The final output will be, so 1 comes here, 0 0 0. What is this? This is 8. And why this is coming as 8? Because in 1 you first multiplied 2, you got a 2, then you multiplied 2 again, you got a 4, you multiplied 2 again, you got a 8. So whenever you have one left shift n, whenever you do something like one left shift n, this is equivalent to saying 2 raised to the power n, because every time the multiplication will be of 2. And similarly, if you do a right shift, let's say x right shift 1, it will be a division by 2. So if you do 7 right shift 2, it will be the division by 2 times. So this is something that we have to keep in our mind, that if you just want to immediately calculate 2 raised to the power n, I can just do 1 left shift n, because 1 left shift n is multiplication of 2 n times, right? So these are the left shift and the right shift operators. I'll just quickly show you the 2 raised to the power part. If you do, let's say 1 left shift 4, okay, 1 left shift 4 is 2 raised to the power 4, right? What is 2 raised to the power 4? It is 16. One second. So you can see you're getting 16. This is the left shift operator. If you see the right shift operator, 7 right shift 2, sorry, 7 right shift 2, it is going to give you 1. Right? And that's how right shift operators actually work, right? So these are the different bitwise operators. Finally, you have something like not operator. You have something like a not. It is technically a bitwise binary ones complement. For example, if you do something like this, complement of 5. So it is going to go bit by bit on 5 and convert the bits. If you see the value, you're getting a -6. Now this might be confusing to you, that okay, technically, if you do this of 5, and let's say we have a 8-bit number 0 0 0 0 0 1 0 1, if you do a complement here, it should technically become something else. Why it's becoming -6? Now this is going to be a cliffhanger. I'm going to talk about this cliffhanger later in a few classes, when we will actually understand how negative numbers are stored inside machine, because this is something important. Negative numbers are stored in a very different way than other numbers. So we are going to talk about it. We are going to talk about how numbers and characters are actually stored inside the memory in C++. Then we will get a better understanding of the complement operator. So for now, you can just say that it's going to do the complement of the given number. How it is doing that and what can be some good examples, we will talk about it in the later upcoming set of parts. So now we are going to actually talk about that whatever like implementations we were doing, we were hard coding the values. Currently, we are able to hard code the values and compute the value and show something to the user. But how about if I want to take input from the user, that the user gives me some input, right? Because in any software, it's not always about you showing something to the user. It's all about user interaction also, that user also gives some input, and based on that input, you take some actions, right? So in order to take user input, so for user output, you were able to do cout, right? Standard std cout. For input, you can do std colon colon cin. In cout, you have opening angle brackets. In cin, you will be having closing angle brackets. And this is how you can actually take user input. Let me show you. So let me prepare the boilerplate. Right. Now let's say I have two values x and y. So let's say we do int x comma y. So you can see I have just declared the values. I have not initialized the values. Only declared. Why? Because the values I don't want to initialize with something specific. I want to initialize it with whatever the user is going to give. So if I do std colon colon cin x, right, and then I do std colon colon cin y, okay, and you can take more than one input also. For example, let's say we have one more variable z, so along with y you can also write this as z. So you can chain, just like you chain multiple couts, you can also chain multiple cin. And let's say then we do std out x plus y plus z. Let's add all of the three values and then show the output. Okay, so let's see. If now you will run this code, can you see the terminal is stopped? Terminal is not computing anything. Why terminal is not computing anything? Because it is currently waiting for my input. In line number 5, it created three variables in the memory with garbage values. You have not initialized it with anything. It is going to initialize it with some garbage value in C++. Then it goes to line number 6 and waits for the input for x. Let's say I give the input for x as 7. You will press 7 and press enter. It is still waiting. Now, because it goes to line number 7 and it is waiting for the input of y. Let's say I give an input of y as -3. And now it is waiting for the input of z. Let's say input of z I give as 5. The moment I press enter, it gives you the output 9. Why? Because 7 minus 3 is 4, 4 plus 5 is 9, the output is 9. This percentage sign you can just avoid because this is coming due to just my terminal. You are not going to get it most probably. So you can see you are getting the value 9. So this is how you can take input from the user. Right, this is how you can take multiple inputs. If you want to take multiple inputs in the same line, you can do this. Or if you want to take inputs in different line, you can do this. This will help us to open plethora of options because user now will be able to put different type of values. We will be able to test with different type of values. We'll just write a generic logic, and based on different available values, we are going to test that logic. So a lot of things can be done now based on how you can take the input, user input. So it's very easy in C++. You have to just write C in. Whatever is the data type that you have defined for the variable, the same data type value will be inserted in the variable, and that's it. This is how you take user input in C++. So one important thing, I just wrote line number 2. Currently I have not taught anything around line number 2, so you can just avoid line number 2. Right, you can avoid line number 2, everything will work fine. Line number 2 has a separate meaning. We'll talk about it in the namespace lectures. Right, so if you just run it again and give the same input, 7 minus 3 5, you are going to get the same output. That line is not mandatory currently because it is not required. We are mentioning std here. We'll talk about namespaces in the further upcoming sessions. So I hope the basic concepts around operators is clear to everyone. I hope most of the concepts that I taught are clear to all of you, and you guys are able to get a hang of what is actually expected when you're actually dealing with a bunch of operators. That being said, let's just wrap this particular video here. We're going to meet soon in a more set of videos where we're going to talk about more concepts around C++. And if you have not yet subscribed to the channel, do consider subscribing to the channel. We are going to put some really awesome content on this particular channel regarding tech and software industry. That being said, I will just wrap this particular session here, and we will meet soon in the next set of lectures. Till then, take care, guys. Bye bye. I am Sanket Singh, signing off.